Hi, everybody. Thank you for joining us today at Data Nova, taking data mesh from theory to practice. We're going to be discussing today managing the data product lifecycle. I'm Alison Huselid, SVP of Product here at Starburst, and I'm joined today by Vishal Singh, our Head of Data Products here, as well as Patrice Linel, a Senior Manager in Data Science and Data Engineering at Genus PLC. So let's dive right in. So from there, I wanted to cover some of the just key points, a really high-level overview of what you need to understand related to data mesh. Ultimately, data lives everywhere, in different geographies, in different locations, in different storage, and different technologies. Data is distributed because the distributed teams are empowered to choose the right technology for their specific use cases. And Starburst empowers organizations and their teams to get better insight from all of their data to drive the business forward. Organizations can access all their data without any data movement. They can organize data into logical domains as per their use cases and create customer-focused data products that can then be discovered, shared, and consumed by anyone in their organization. But before we dive into the details of data products and data mesh, let's see how data centralization can be a bottleneck in driving business goals faster. Centralized data efforts can be a challenge in several ways. First, building pipelines to move data around can be surprisingly complex and fragile. Second, no one person can be an expert in all the data across any modern company. It's just not feasible. Tasking a team with owning expertise in data logic across business units is often the challenge in centralizing the data and can lead to significant bottlenecks. Finally, combining data from disparate sources and in multiple formats is a common repository challenge where there's little to no forethought or even cooperation from the data producers who have their own data jobs with their own milestones and goals to hit. The data just isn't a focus for them in the same way that their product-driven goals will be. And so going on to some of the pillars of data mesh, we've got four main pillars. First, a domain-oriented ownership and architecture with data as a product, having a self-service data infrastructure, and then federated computational governance. With data mesh, the focus is on letting the subject matter experts with the most knowledge about the data use it to create data products. These data products are produced by the domains themselves, the data producers. There's no more central data engineering team creating a bottleneck for all data curation because it happens instead within the domains. Given that, let's try restructuring things. Move the data engineering efforts into the product teams, the domain areas. The domains, by definition, are the subject matter experts who create the data and understand best how to curate it. So we'll add to the charters of these data producing teams and do what's necessary to make sure that data is an actual product they're responsible for. That is, let's adjust their goals, their OKRs, and adjust the staffing models, their responsibilities, and product ownership to reflect the fact that data is a full-fledged, first-class product that teams are accountable for. In the end, this will serve to remove the bottlenecks and improve the flow of data from the source to the consumers. And the data that these domains produce are their data products. In this example, these are the middle row, things like merchant performance and user profile data. This functionality removes the central data team, and then we're on our way to a more streamlined data ecosystem. So at Starburst, we're taking a middle of the road approach and defining a data product as the data itself, its metadata, and the access pattern. In reality, a data product can range from a simple cleansed list of transactions to a highly curated and complex group of data sets. In practice, data products are frequently far more complex and can even be used to produce other data products within the same or different domains. For example, user profile information can be combined with product information to drive a marketing effort, which then in turn are used to create a customer value data product. So from there, I'm going to hand it over to Vishal, who can give you a demo of data products at Starburst. Over to you, Vishal.
Thank you, Alison. For the demo, I'm going to be using 3 different personas to talk about data products and go through how easy it is to curate the data set and how easy it is to share the data set with different persona in the organization. You can see one of the persona is Aaron, the system admin. Other persona is Katie, who is the marketing and sales admin. And the last persona is John, who is the external vendor coming in the organization to work with the data set. If you look, they all, Aaron, Katie, and John has access to the same endpoint, but their view of the data set is very different from which organization or which day-to-day activities they're responsible for. If you look at the Aaron has access to all the data sets in the organization, no matter where data exists. It could be on Azure, BigQuery, Salesforce, Snowflake, SQL Server, anywhere. Aaron is looking at all his data sets. If you look at Katie, Katie only looks at the curated data set because Katie cares about the business context of the data. And Katie wants to get access to the data set so that she can drive day-to-day business activities. Now let's look at Katie. Katie cares about the data itself, but Katie also wants to know what business context does data bring. Now, if Katie wants to search for a data set which contains mortgage information, as Katie types mortgage, Katie is able to search the data set which contain the property mortgage right with few clicks. Katie can also double click into one of the data set and get the brief description of that data product. Brief description how this data product has been used over last 7 days and 30 days, and by how many users. Also, how many data sets belong in this data product. Quickly understand some usage examples, like what basic queries I should be writing to get started with the data set, or may participate in some discussions which are already being happening in regard to that data product. Katie also knows the data product owner for this data product is Aaron. Get 2 tags, customer and region, and can add more tag to organize the data set, which makes more sense for Katie. The data set belongs in domain marketing and have some relevant information, which is either could be external link or a conference page or a Google Doc, which may not or could not be captured in the data product page. And some details around who created it, who is consuming it, and what was the last person who queried the data set. Katie can also consume this data set using any BI tool of their choice, or view the data set in the context of this data product from previewing this data set. Katie doesn't care about where data exists. Katie cares about, do I have access to my customer data or not? Katie does not have to know, neither have to care which data exists is in a warehouse or a lake or Oracle or anywhere. Katie now have access to the customer segmentation by first name, last name, estimated income, product, credit card number, which is masked for Katie, mortgage ID, customer segment, and credit card type. Now let's look at the John's view. John has also been tasked to look at the same data product. But John, instead of searching mortgage, comes and search data mesh. And as John searched the business term data mesh, John is able to also find the exact same product, but was able to use different term to find it. Because search goes through every metadata which was used to capture and create this data product. John also previews customer segmentation to understand what kind of data do I have access to. As we got a view for John, John has first name, last name, but John cannot see estimated income, which Katie could. And that's the aspect of data products bring if different users have completely different view of the data set in the data product based on the domain or the role they belong to. Credit card number is still masked for John. One thing I like to also point out, in the customer segment, John just have access to silver segment, while Katie could see gold, platinum, silver, and gold. John has been just hired to work on the silver customer segment. Thus, John has been given to just see the silver customer segment. Now, Katie reaches out to the product owner, Aaron. Can you share me some customer order information data set too? Customer order information data set exists in BigQuery and Snowflake. In Query Editor, if you look at the Katie's view, Katie does not have access to BigQuery or Snowflake. How easily can Aaron, who is the product owner, create a data set, cut order information, and share with Katie? This is the query, which contains the information about order information coming from Snowflake and BigQuery. You can take this query. As Aaron, who is the product owner, I can edit this data product. Add a new data set. Now, Aaron has two options when Aaron is sharing this data set within the context of this data product. Aaron can either use view, which is a live view, data coming directly from the sources when the user queries a data set, or a materialized view, where data will be cached locally in the object storage. So instead of data being fetched from BigQuery and Snowflake on demand, data will be fetched locally from the cache in S3. I can add some column description. More metadata will help to fuel the more search for data consumers. So the more metadata is useful while creating the data product. I'm going to skip this part for now. Save and continue. I look at the Aaron, who is a product owner. I'm going to leave that. That looks great. So are the tags, and so are the relevant links. Here you have pending changes that has not been published, and you can see the information, and Aaron is publishing a new data set in the context of the data product customer. As I publish, now if I go back to the Katie's view and refresh this data set, Katie now has access to order information. Katie doesn't know where the data is coming from. Katie still does not get the access to Snowflake and BigQuery, but was able to get access to the data set living into two completely different locations without giving access to the raw data set itself. If I preview the data set now in Katie's context, Katie should be able to see the raw data set, which is, curated data set, order information, and can work on it. Data set is also being shared with John because John also have access to customer data set. Going back to data product, as we talked about, data product also belong to domain. So one domain is a higher hierarchy, which contains one or many data products. Domain is the logical groupings of use cases or maybe organizational structure, and can be used to give access and share the data products to different users in the organization. For example, Katie has access to all the domain, but Katie is marketing and sales admin, which means if Katie goes to look in the data product for marketing, Katie can edit the data product, delete the data product, and change the data product. While if Katie goes to the finance or sales department, then Katie should not have any edit privileges because Katie can only consume the data products for those departments. So that also creates the logical representation of who is the admin for what domain. In John's case, since John was just hired to work on the data products in the marketing domain, John cannot even see the other domain. John can just see the data product for the marketing domain, and can you only see the data product if they are published in that domain. And that creates the ways to share the data product based on which persona you belong to and what your role is in the organization. That is my data products demonstration. I'm going to hand it over to Patrice to take over for the next use cases.
Thank you, Vishal. So welcome, everybody. I'm Patrice Linel. I'm the Senior Manager for Data Science and Data Engineering at Genus. I've been a computational scientist by training, worked the last 10 years in high-performance computing, computer science, and biostatistics. I joined Genus back in 2014 after my postdoc, and since then, been leading the scientific computing group and now the data science and engineering group through this data journey. So Genus is a world-leading animal genetic company. We partner with farmers to nourish the world more efficiently and sustainability. And we do this by looking at the DNA of the animal and looking at traits of interest for the farmers. And we help them produce high quality meat and milk more efficiently and sustainably. When we select the animals based on their area in the DNA of interest and the strongest, and we only retain the strongest genetic profile. We deliver these strong animals back to farmers by breeding animals, semen, or embryo. And we do this for the bovine or porcine world. Our ABS global business is looking for bovine animals, whether it's milk or beef, so dairy or beef, and our PIC business is for the porcine. So our data mesh journey is based on a data-centric approach. It all started from the realization that the current state of the data would not allow or would make very difficult data analytics and machine learning at scale. And this would require data sourcing, managing the data in terms of storage, policies, governance, accessing all this diverse data, and then shifting from a system or use case focus to a data-centric focus, meaning we wanted our data to be fair, findable, accessible, interoperability, and reusable attributes. So with our group, we pioneered our way to a solution that allowed for better and faster analytics at scale, but that needed major shift in architecture, technology, operations principles, and those were guided by the data product pillars and data mesh journey. So we wanted federated computational data governance, data products, self data platform, self-service data platform, and data ownership. So when we looked at our data platform technology, we wanted an ecosystem that was manageable and that could realize the data mesh architecture. First was a platform for data computing itself. We absolutely needed SQL compatibility because of previous tools, current tools, and BI tools that we were using. We needed support for data lake, especially S3, but other cloud lake providers, and multiple file formats with the diversity of the data that we had. And anybody that worked in big data understands the importance of working with compressed data. Next was data access, authorization, and authentication. I think Vishal did a great demo on what that looked like in Starburst in terms of being able to authenticate to a global IT system, but having different level of authorization and access to the data. We also needed cloud native, and that's a big, I would say, architecture decision for us in terms of we wanted something in the hybrid forms that could be deployed whether in the cloud or on-prem and support a containerized environment, in our case, Kubernetes. The next point talks about federations of data sources. And that is another important point of the data mesh. We do not, at least at Genus, we're a small team, and we cannot transform the entire business and operation to a single data technology. So we have to deal with different types of technologies from different years and all of that. And so we wanted something that could federate all those data sources into one platform. I already talked about the support for major BI tools, but with the new departments and the direction we're going for analytics, we wanted to support those workloads. And probably the most important is discovery. How does someone that's new in the business knows that, oh, this data is available and I can go and myself use that data platform and bring the value out from the data. So for us, our data mesh ecosystem looks like this with Starburst at a central position. We have different, like I said, data lake technologies. We also have a lot of Excel spreadsheet, and you will see me smile with that one. But we also have different database technologies like SQL, Microsoft SQL, or Oracle, or MariaDB. And we needed tools for the data engineering team, but also the analyst to be able to work with this data. And so DBT is a big one for us in terms of production of data product, but we use Python and Metabase and Power BI. On the data science side, it was very important that we could directly access the data product with Shiny or Streamlit applications. So when we looked at data products, our goal was to have analytical data shaped to fuel data science and to enable us to make better insight and decisions from all the data that we collect from the farmers and from the animals. The main question is, well, how do we serve this data? And what exactly are we serving people in terms of data? And so we still needed to address the data quality, the documentation, the self-serving aspects. We need a way to have all the trustworthy attributes of a published data product, like the freshness, how often was it used, and by who. For data products, we know that product doesn't exist without code. And for those of you that are familiar with microservice architecture and software development, it's a little bit of the same concept where we needed to be able to reproduce our data product at a specific version and track the history of those data products and do that directly from the data sources. Another pretty strong attribute of our design. Discoverable and understandable, understanding the data through the data cataloging. And in our case at Genus, we use Elation for data cataloging. And this data needs to be valuable and interoperable. And that's a big point for us, because once you publish a data project, it rarely lives by itself. It brings value in our data science world when we join this data with other data from different domains. And all of those access to data needed to be native and secure. With Starburst, we can connect to multiple data sources in the database. We had our analytical SQL with fast scaling, massively parallel process engine. We could measure access, allow the self-service from a data lake and the data exploration point of view. And most importantly, the current team could use the tool that they were most familiar with, like Metabase and Power BI. So when we looked at what we had pre-data mesh, we had a spaghetti architecture. Everything was interconnected, and there was no real thought architecture for the data flow. It was solution or system-focused project and effort with mild success and little share and reuse. For data engineers and data scientists, it was an obstacle course to gain access to the data, understand it, its quality, and there was no documentation. We had to schedule multiple meetings and chase human knowledge about it. When we looked at the data engineering process, it required 3 steps that was needed to be able to join that data from different sources, and we had to do a lot of ETLs for that. That resulted in slow analytic response time to other questions from our leadership team. And that's really a pain point that we wanted to alleviate. In terms of business outcome for data mesh journey, because this is a journey and we're not at the end yet, we're looking at the benefits of the platform architecture that we just put in place. It's a simplified architecture. It's easier to manage. We have the data engineering process under control. And right now, we're able to see that analytical queries and data product creation and validation are up to 150x time faster compared to our previous version of the warehouse on certain workload. That directly resulted in accelerated data discovery and usage in data science projects. When we look at the journey at Genus, for us, this is I would consider that we are in the middle of this. We are already reaping the benefits of the data architecture that we choose, but also we have to keep pushing on the data product side and self-serving aspect of it, so to bring our colleagues with us on this journey. Thank you very much.